Find the number of integer solutions to the equation x1 plus x2 plus x3 is equal to 7. Well, the question doesn't end here. There are some conditions given. x1 should lie in the range 0 to 2, x2 should lie in the range 0 to 4 and x3 should lie in the range 0 to 3. In week 1 we have also seen such questions where, rather in counting chapter, we have seen questions where we are just asked to find the number of solutions for the equation without any such conditions. But now we have to follow these conditions and find the possibilities which fit this equation. Now, if I consider n to be the set of all possibilities, we know that it is going to be 3 plus 7 minus 1, choose 7. How? By the concept of sticks and cups, you know that n is 3 here, r is 7. So, by the formula, it is n plus r minus 1, choose r, and hence it is 3 plus 7 minus 1, choose 7, which is 9, choose 7, which happens to be 36. Now, this is all possibilities. But don't you think we are overcounting? Because here you would have even those possibilities where x1 is at least 3, right? It is at least 3 here, whereas the given condition is it should lie in the range 0 to 2. So we are overcounting some possibilities. Now, the next step would be to subtract all those unwanted possibilities. How do we do that? Let us set C1 to be the condition where it has solutions with x1 greater than or equal to 3 and C2 to be those solutions for the equation with x2 greater than or equal to 5 and C3 to be the condition where x3 is greater than or equal to 4. So these are the 3 conditions. So I am setting the conditions this way. I am going to see what is n of C1. How do I calculate that? I have to find out all those solutions where x1 is at least 3. Now, it is precisely finding out the solution for the equation x1 plus x2 plus x3 equals 4. How did I come to know this equation? It was x1 plus x2 plus x3 equals 7 minus 3, which is 4. Now, adding 3 on both sides, adding 3 to x1 and to the RHS, it gives me the original equation. Did you observe what I am doing? Take a moment to think and understand what is happening here. In how many ways can we get solution for this equation? It is nothing but 3 plus 4 minus 1, choose 4, which happens to be 6, choose 4, which is 15 because it is 6 into 5 by 2. Now, moving on to number of elements following C2 condition, that is n of C2, it happens to be the solutions which are having x2 at least 5. Now, following on the same lines, it is precisely asking the solution to the equation x1 plus x2 plus x3 is equal to 2 where x2 happens to be at least 5, right? Now, what are the solutions for this equation? It is 3 plus 2 minus 1, choose 2, which is 4, choose 2. And 4 choose 2 is 4 into 3 by 2, which is 6. Now, following the same for C3, the solutions where x3 is at least 4, we have to find out n of C3. Now, it is the same thing as asking the solutions to the equation x1 plus x2 plus x3 is at 3. How many solutions do we have which satisfy this equation? It is 3 plus 3 minus 1, choose 3, which is 5, choose 2. 5 choose 2 happens to be 5 into 4 by 2, which is nothing but 10. Now that we have calculated n of C1, n of C2 and n of C3, we move ahead to see what is n of C1, C2. What does C1, C2 mean? x1 should be at least 3, x2 should be at least 5. Now, the moment I insert x1 to be at least 3 and x2 to be at least 5, the sum becomes 8. Boom, we cannot go ahead because we must get x1 plus x2 plus x3 to be 7. It is not going to happen here. And hence, n of C1, C2 is 0. Now, C2, C3 is x2 should be at least 5, x3 should be at least 4. Even if you substitute x2 as 5 and x3 as 4, the sum is 9. You cannot proceed ahead and hence n of C2, C3 is 0. What happens with n of C1, C3? N of C1, C3 is those solutions where x1 is at least 3 and x3 is at least 4. If I substitute x1 to be 3 and x3 to be 4, it is satisfying the condition because I can substitute x2 to be 0 and hence the sum is 7. Well, this is the only possibility here. Why? If I swap x1 to be 4, it is possible, but x3 cannot be 3 because it must be at least 4. And hence, no other solution is possible. The only possibility is 3, 0, 4. x1 3, x2 0 and x3 4. And hence, n of C1, C3 is 1. Now, what about n of C1, C2, C3? If all three conditions must satisfy, that x1 must be at least 3, x2 must be at least 5 and x3 must be at least 4, then the sum is going to be at least 3 plus 5 plus 4, which is 12, which is an invalid solution, and hence n of C1, C2, C3 is 0. Now, the question is, how many solutions exist for this equation with these conditions? Right? So, what do we have to calculate? N of C1 bar, C2 bar and C3 bar. N of C1 bar, C2 bar, C3 bar here is equal to S0 minus S1 plus S2 minus S3, which is nothing but 36, which is S0. S1 is 15 plus 6 plus 10, which is 31. So, 36 minus 31 plus n of plus S1, which is n of C1, C2 plus C2, C3 plus n of C1, C3, which is 1. So, 36 minus 31 plus 1. And last one is minus S3, which is 0 here. So we need not worry about that. So the final answer is going to be 36 minus 31 plus 1, which is 6. So the number of integer solutions to the equation x1 plus x2 plus x3 equals 7 satisfying these conditions is 6.